Hello everyone. This is a demonstration of our project Enhanced Multi-Modal Object Detection using Unit-Centric Feature Fusion. Let me explain it clear. This consists of a pipeline which includes unit segmentation and YOLO V11 detection. V11 is a latest model of the YOLO, which is a you only look once model, which is used to detect objects in computer vision. Coming to the pipeline of the project, so it has a data collection and feature fusion, and then unit based segmentation, and then attention mechanism, and then we go to detections using YOLO V11. Here, as you can see, the dataset is split into two parts, which is visible image and infrared image. As mentioned, a multispectral images consist RGB image, which is red, green, blue, which is a visible image, also called a image which is visible to our naked eye. I mean, which we can see is considered as visible image. And infrared image is something which is which is separated like thermal image, which only portrays white and black image from the computer vision, which something looks like this IR input. Then a masked image is generated, which separates the foreground and background clearly by adding efficient white and black color to fore and backgrounds respectively. And then feature fusion is done and sent to unit based segmentation. Unit segments the masked image, and then it transfers it to feature extraction. As you can see, this will be the predicted mask, and here the unit segments the objects, and then it gives attention mechanism as mentioned here, which will not leave any relevant information that is completely focused or completely important. This attention mechanism carries the important and relevant information to the detection head, which is of YOLO. YOLO has three layers. Feature extraction is a backbone, and self attention mechanism in the neck, and detection heads, which will completely detect objects in the given frame. And then if the objects are detected using bounding boxes, they are clearly highlighted and represented. And these are two folders which consists of IR and masked folders. These datasets are sent to unit, which is developed here. This is a unit architecture, or a what you call unit model declaration, and this is how it looks. Unit has been successfully created, which undergone training for both these folders. Let's move to detection part for the YOLO model. And this model, final model.bkeras, is the unit model which we have saved here. So this has been uh, loaded here, and then the substantial results have been sent from YOLO from unit to YOLO 11, and then yeah. This is a predicted mask image as I shown previously in the presentation slide, and this is a completely separated image from background and foreground, and this assists YOLO model to betterly detect with high confidence score objects, and leaving irrelevant information which is a stone or something else. So this makes the model more efficient and applicable in foggy environments, rainy conditions, and when where the vision is unclear, or which is where the model or a computer machine cannot see clearly the objects. So let me brief it entirely. As I said, if the objects are clearly visible in the RGB image itself, it will be directly sent sent to the detection model. Else, if the model or the image of the vision is unclear, then it moves to infrared images and classified to masked images. And then this whole entire process goes on. This process, where IR input and predicted mask are completely overlapped between overlapped onto each other, they produce something true mask, which is like this. And if this true mask has been overlaid onto this original RGB image, it clearly separates the background and foreground objects, which will assist and enhance the functionality of the detection model, which is YOLO in this case. And you can see the clear results with improved confidence score of the bounding boxes, which is shown here. Thank you for it. Thank you for your time.